Hello everyone, I thought I would make a video about recursion because it's kind of a difficult topic to really write about and get a good sense of what recursion is and how it works. So, made a little PowerPoint presentation and then we'll get into some code here. Yeah, let's jump right in, shall we? So recursion, what is it and how does it work? So, what is recursion? Recursion is a fundamental technique of computer science which can be applied to solving many types of problems. Um, a more direct and kind of academic way of describing it would be the process in which a function calls itself directly or indirectly. That's called recursion, and the corresponding function is called a excuse me is called a recursive function. Um, but to make it a little bit easier for like people that maybe don't want to hear something coming from like an academic journal or like Wikipedia type confusing language, this would be an easy way to explain it. Recursion can be used to solve problems that can be broken down to smaller identical problems. So think of a Russian doll. We're going to keep going, taking apart one doll at a time until we only have one doll left. That's how recursion works, and it'll make a little bit more sense once we get into the code. But when do we use recursion? Recursions are really good. Recursive function, is really good for sorting algorithms, working with files and directory structures, or parsing XML or HTML files. XML and HTML are more towards like HTML being hypertext markup language, being like websites and things of that nature. It's basically the structure that goes into a web page. Little bit of information on that later on. But right now, it's really not that important to really understand it, since we're more worried about recursion and for sorting algorithms. Just a little bit more information though on here that I decided to add on is that you may have seen recursive acronyms such as GNU, which basically stands for GNUs, not Unix. Kind of a stab at Unix systems. Or PHP, which would be PHP hypertext preprocessors. And then a little meme here. In Soviet Russia, animals are recursive. I don't know. I thought it was punny, and that's just but yeah. So let's get some code. Let's get some code going, shall we? All right. So now we are in the IDE. I'm using IntelliJ IDEA Ultimate. And I set up a class called recursive because we're talking about recursion here. And what we're going to do is we're going to create a recursive function that can go through and solve factorials. In case you don't know what a factorial is, it's going to be represented with whatever number factorial that we're looking at plus an exclamation point. And I should probably go through what exactly that means. So like we'll solve it for 5 here in this example. But what that means is that we're going to have 5 times 4 times 3 times 2 times 1, which should give us an answer of 120. With that being said, like having 5 times the factorial of 4, which again is just showing the same exact thing here, of 5, and then we have the factorial of 4, so 4 times 3 times 2 times 1, which would equal 120. And then, you know, 4 to the, or the 4th factorial, or excuse me, yeah, 4 times factorial 3, which would be, you know, 4 times 3 times 2 times 1, which would give us 24, and then 3 times factorial 2, give us 6, 2 factorial 1, give us 2, and then 1 factorial, it just equals 1. So we could do something like this. This is what we have been working on, where we just take, you know, 5 times 4 times 3 times 2 times 1. If we were to print this out, this will take it a second here. we're going to get 120. Or if we decided, we just wanted to see what the factorial of 4 would be, run this again, and we'll get 24. We wanted 3. 3 times 2 times 1, so there's 6. And it's already given me like simplifications here, but there's a reason why we're doing it this way. 6, and then you just keep on going, take out 2 times 1, which should be 2. There's 2. And if we just printed 1, yep, so we could do something like that and still come up with all the factorials, but what if we wanted to write a function that was able to solve our recursive, solve factorials through recursion? What we could do here is we can set up a method that takes in an argument called n, and the reason why we're calling it n is just to represent whatever number we're using. In this case, it'll be 5. And since this is not a void function, we will be able to put in some business logic here into this method that will basically go through and solve once it hits whatever our base case is. So basically, it's going to go through and it's going to keep on going until it hits a base case, but it's going to store everything that we did before in memory, and then once we hit that base case, it basically is going to say, hey, we found the solution to what, and in this case, our base case is going to be 1 factorial, which would equal 1. It can then go back and then solve all of the others that we previously set into memory recursively and give us the answer for the factorial n that we're solving for, which would be 5. Trust me, it's going to make sense here in a second. So let's put in some business logic here. So if n is less than or equal to 1, we're going to have to return a value, which will be 1. And this is called our base case, because 1 factorial equals 1. And then if it isn't 1, we'll set an else, and we will have it return our number times factorial, whatever our number is, minus 1. So this is what's going into memory here. This is what is going in memory. And we're going to be able to have this function solve itself once we hit that return base case. So in order for us to be able to call it within our main method, since this factorial method is outside of our main method, we have to first off print something out to the command line, and we'll call factorial. Boy, I'm getting so many texts today. Just put that over there. Ignore it. And then have factorial be called, and then have our number equal 5. So once that goes through, we should see 120 populate. Happening. Going through the Give me a second here while I debug this. And you know what? I figured out the problem. I had this set as n is greater than or equal to 1. So of course 5 is going to be greater than or equal to 1. So it's just going to return a 1. So that's why we're getting 1. Okay, so we'll run this again here. See if we, yep, see, there we are. We're at 120. So what I also wanted to do here was go through the debugger tool and kind of see where or what exactly is happening. So we'll rerun this again. Okay, still got the same thing. Now we'll debug it. First things first, it's creating an in our arguments, we've got a string at the 0 index at 804. Kind of see that we're now in this if statement because we were here. We said, please print whatever our method factorial is with our argument 5. So you see factorial long equals, and then we're saying basically add 5 into here. And now it's going through and it's saying n equals 5. So if n is less than or equal to 1, return 1, but it won't because 5 is greater than 1. So it's just going to take a next step, jumps in this else statement, and is saying return 5 minus, or 5 times the factorial 5 minus 1, so we'll get 4. Then it's going to step back and go through. It's going to say, is 4 less than or equal to 1? No, it is not. So then step back into this else statement again, saying 4 times 4 minus 1, so we should get 3. Yep, so n is 3 for variables. That's what n is saying. So is n less than or equal to 1? No, it is not. Return 3 times 3 minus 1, so that's going to equal 2. And I was correct. If n is less than or equal to 1, return 1. It is not, so go back to this else. 2 times 2 minus 1 will give us 1. If n is less than or equal to 1, return 1. 1 is equal to 1. So we hit that return 1. And that will basically go through, and it's basically going to go and step down from here. We're getting like, this is kind of what it's doing. It's saying, okay, 5 factorial, okay. Take 5 times 4 factorial, then 3, 2, 1. Once it hits that 1 equals 1, it can now go back up this chain and solve everything else, is what's happening. And that gives us our factorials. So again, we just go print that and equals 120. Yep. So that is how recursive functions work and how they're important, especially when doing something like breaking down the factorials. There's lots of other things that I can do. I could show another one if you're interested, in which we break down the Fibonacci sequence, which is basically just adding a number to the previous number. So it'd be like 0, 1, 1 plus 0 equals 1, and 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 2 equals 5, and so on and so forth. We could solve things like that. It's kind of a, like, the big thing with them is that they're pretty common in algorithms, and they work pretty well. So hopefully this kind of explains breaking down a function, and from there using recursion to keep on breaking it down into smaller parts and returning what we have. Yeah, like I said, if you had any other questions or want to know about like the Fibonacci sequence and how we can write a recursive function to solve that, just let me know, and I can get that as a part 2 to this assignment. All right, thanks. Have a great day.